It's 9:02. We may as well start. So with that, let me remind people to stay on mute if you'd be so kind, other than when you're actually presenting, if you are. We have, again, a very large number of people anticipated to sign on today, over 400 people registered for this, our first of 3 sessions on carbon and hydrogen innovation and its applications, of course, in the oil and gas sector, but more broadly. So welcome on behalf of Foresight and the Clean Resource Innovation Network to the first of 3 sessions, where we'll feature some of the most exciting startups in this space, as well as the journey that Canada's oil and gas producers are on to try and engage with these emerging technologies. I'm Jason Switzer. I'm the VP for Growth and Capital at Foresight. Foresight is Canada's largest cleantech accelerator, and we'll tell you a little more about us momentarily. But before we get started, I think I'll take a moment to do a land acknowledgement. At Foresight, we acknowledge that the lands on which we work and live are the traditional, ancestral, and unceded territories of the First Nations, Inuit, and Métis people. It is, I guess, a journey that we're all on around reconciliation. And so I hope we can all take a moment to think about this and about the challenge of climate change. Our CEO, Jeanette Jackson, is here, just recently returned from Scotland at the COP, where the Indigenous voice was very strong. And I hope can share a little bit of reflection on what that event means and how it affects this effort that we're coordinating to try and accelerate the commercialization of technologies in carbon capture, utilization, storage, hydrogen, and methane decomposition. All right, a reminder that this event is being recorded and that the video will be available to all participants. And of course, please, again, stay on mute. Here's a quick overview. We'll be moving very shortly to a panel featuring the experience of Cenovus Energy and Svante working together to commercialize their carbon capture technology as applied to a heavy oil asset in Canada. We'll then move into a series of company showcases in which we'll listen to pitches from some of the most exciting carbon capture and conversion ventures in Canada and elsewhere. We'll move to a Q&A, and then each of the entrepreneurs will host a breakout room where if any of our participants are interested in diving deeper and having the opportunity to engage more fulsomely on the technology and business model, and ideally look to how the CRIN network can support these ventures in commercializing and growing and pulling carbon out of the atmosphere, that they'll be able to do so. And then we'll close at 10:55 sharp. I do hear some background noise, which suggests to me that someone's not on mute. So once again, just take a moment. Let me talk for a moment about CarbonNEXT and these innovation showcases. So, of course, the Canadian oil and gas industry, both through its voluntary commitments and net zero ambitions, as well as with emerging commitments from the federal government, is working to decrease greenhouse gas emissions. And in that context, carbon capture and conversion, hydrogen, and methane are areas of key interest to enable the sustainable development of Canada's hydrocarbon resources. And over the course of these 3 workshops in November, February, and March, we'll be working together to connect elements of the industry across the value chain, from producers and shippers right through to energy service companies and other partners, in the ambition of mobilizing these technologies and accelerating their commercialization and widespread adoption. Next slide, please. Of course, this is hosted by the 2 of us. Our partnership is focused on helping support these ventures. CarbonNEXT is a joint initiative of Foresight and Carbon Management Canada, and you'll be hearing from the CEOs of both organizations. And so with that, let me turn it over, or let me just say a quick word about CarbonNEXT. CarbonNEXT, one of the great challenges, of course, and we can talk about this some more, is the need to commercialize the next generation of CCUS solutions, as well as to ensure that CO2 is pulled out of the atmosphere, that it is sequestered and turned into products, and that we're able to ensure that CO2 remains there. And that calls for a really ramped up effort to grow the number of ventures to support their journey and to better connect them to industry partners and investors across the commercialization cycle. So building on Canada's early leadership in CCUS, CarbonNEXT was established to streamline that journey for innovators and industry partners across the set of technology areas that I just outlined. We leverage the largest pipeline of cleantech startups in Canada, working with over 100 of these in a given year through Foresight Canada. And of course, our partner, Carbon Management Canada, provides extraordinary experience in this space, its knowledge, its connections, its technology testbed facilities, and experience supporting industrial deployment is unparalleled and really demonstrates the leadership that Canada has taken in CCUS technology development. With that, let me hand it over to Matt McCullough, our colleague representing Exergy and CRIN today, to speak to CRIN and the journey in CCUS that the oil and gas sector is in.
Thanks, Jason. Yeah, just super quickly, just to introduce myself, I'm Matt McCullough, Vice President of New Energy Technologies at Exergy Solutions, where we work with technology providers directly to accelerate both development and deployment of their technology, supported by 3D digital solutions and additive manufacturing. But we also work directly with industry as well on their greenhouse gas technology strategies and evaluations and supporting deployment on that side. So act as that bridge to help to accelerate the development and commercialization of new promising technologies. So, but also a part of CRIN's low emission value added product theme, which we are super happy. Myself and Brian Heffelbaum from Alberta Innovates, who the two of us helped to make sure that this happened, and we're just so happy to see it finally come to fruition. Now, I know everyone on the call is CRIN members, otherwise you wouldn't have been able to get on, but just as a reminder of what CRIN's all about. It's a pan-Canadian network of networks, really, that was founded to bring together all the different nodes of the oil and gas innovation ecosystem to really address the economic and environmental priorities of the oil and gas industry. So the ecosystem includes 7 themes, the low emission value-added products being one of those themes. But as you see, so it's covering 19 different sectors, and at this point in time, we have over 2,900 members. And I think that's really sort of even reflected on the participation today. And CRIN's involved with this event because we recognize that CCUS and hydrogen technologies really are a priority area of focus for the ecosystem and a key part of helping progress the network, really to achieve CRIN's vision of Canada being the global leader in producing clean hydrocarbons from source to end use. So just quickly on sort of the context for industry from certainly my perspective. But I would say that CCUS and hydrogen technologies have clearly, and some would say finally, become a priority focus for industrial decarbonization. Really hit that 2020 mark. I really sort of felt an inflection point to occur, and the level of interest and focus on these two topics. So with industry making worldwide net zero commitments, and here in the midst of COP26, industry not only needs to have a plan to reach those commitments, but they also really need to demonstrate near-term reductions to their stakeholders. So deployment of these technologies that are either commercial and near commercial or accelerating the development of those that are a bit earlier stage is really critical for industry. And for many, the only way to really significantly reduce greenhouse gas emissions, if you're sort of carbon intensive heavy industry, is ultimately going to be through carbon capture and hydrogen as two key levers to create those reductions. And of course, while this comes with cost, really the focus is ensuring that these technologies are as cost effective as possible and getting the lowest cost technologies to market as quick as possible, And I mean, you'll see from today that just demonstrates the opportunity that's at hand. So we've really got some new exciting technologies to present today, and really looking forward to the discussion. And these companies are really looking to take root here in Alberta and across the country. So as an ecosystem, it's really up to us to make sure they get developed as quick as possible, not only bring the benefits to industry, but of course to Canada more broadly. So thanks for that, Jason. I'll pass it on to Jeanette.
Good morning, everyone. Thank you for joining us this morning on this exciting conversation with CRIN, of course, as Jason mentioned, supported by CarbonNEXT, which is a joint initiative with Foresight and CMC, now Carbon Management Canada. So Steve and I always have to remember to say it out and spell it out now. For those of you that don't know me, my name is Jeanette Jackson. I'm the CEO of Foresight. We are Canada's largest clean tech accelerator, and we take a very ecosystem approach, supporting the innovation community with connections with industry, academia, government, and of course, capital, to really accelerate the potential of those ventures, of those ideators, those entrepreneurs, those innovators, and more importantly, helping them scale, commercialize much more quickly. As a background for CarbonNEXT, as you're all aware, we're on this call today, there is a significantly urgent demand for clean technology solutions as heavy industry navigates their path to net zero. I was at COP26 last week in Glasgow, and before that, spent some time in Holland for a few days. And even in the Netherlands, they're really looking to Canada for carbon capture and hydrogen technologies. So this network of us coming together today is another example of how we can collaborate to look at export opportunities down the road as well. Despite a growing consensus of the importance of decarbonization, deployment of CCUS technologies has been too slow, and the primary reasons are policy uncertainty and that there's still some opportunity to work through that pilot stage to really prove out these CCUS technologies. As policy signals continue to align and investors are now mobilizing like we've never seen before, if you have been following along, $130 trillion in capital is available. I won't debate some of the metrics and frameworks for that today, but there's a lot of money coming together, and us in Canada have the opportunity to really have some of these bleeding edge and leading edge and even ready to go technologies front and center on the global stage. We have been a global leader in CCUS, and thanks to the large measure of investments made by the oil and gas sector, such as the CarbonNEXT prize. According to the IEA, oil and gas represents 1/3 of all CCUS spending and 3/4 of all CO2 captured, with the Canadian oil and gas sector leading. So we should all really celebrate where we've come and look at collaborating and having more impact moving forward. The next generation of Canadian CCUS innovation needs a different kind of support, as mentioned, sort of that ecosystem approach to really more rapidly identify market opportunities, de-risk the technology, enable pilots, capital, and of course, scale. And it's really partnerships like this that we believe are going to help get us there. So without further ado, I will pass it over to our colleagues, Stephen Lougheed, CEO of Carbon Management Canada, and look forward to a really engaging, fun session this morning. So thank you all, and have a great start to your day. Stephen, over to you.
Great. Thanks a lot, Jeanette. I'm going to very quickly go through a set of slides as well. And I hope everybody can see it here. Once it goes, there we go. Really happy to have this partnership with Foresight and work with CRIN. I wanted to quickly just go over a few elements and announce a new program that we're working on that will be fitting nicely into the CarbonNEXT initiative. A bit about CMC, Carbon Management Canada. Our sole focus is on development of solutions for industrial decarbonization. Heavy background in CCUS and in MMV. We do work across applied research, technology risk assessment. We have a lot of work across sectoral engagement with large industry, researchers, small players, and startups, as well as providing advice to government. This next element's a bit busy, ignore it, other than the last line I'll be talking about is a bit of the partnership we've been working on and that CarbonNEXT will be leveraging with Global Affairs Canada. So a bit about some of the things that CMC is working on. You've heard, and you'll hear a lot more over the next 3 sessions about CarbonNEXT and the partnership with Foresight. I know on this, on the event today, we have members from NRCan, from BC Research Inc. and others. So a lot of these technology research organizations that we tend to coordinate with and work with and really provide a strength across Canada as we get more coordinated. We have some tremendous facilities across Canada that we are leveraging. We've also been working, and Matt's been working with us on some of this and others, working with several large industrial emitters across many different platforms, from cement and steel to oil and gas and utilities. I mentioned Global Affairs Canada. So we've had a series of very good events introducing Canadian companies across a number of embassies around the world, and Global Affairs Canada has been an excellent partner in that. I've got 2 very complex, busy slides that I'll go through next, but there's a single point. So our research facilities in Canada, ourselves and PTRC and others, are probably some of the most intensely monitored subsurface sites for sequestration in the world. And we also are a global test bed for atmospheric monitoring. The point of this is simply, we have the capability to work with large industry, R&D developers, technology service providers to use these test beds to advance the state of the art and accelerate the adoption of technologies. And these are available through CarbonNEXT and through other programs that we're working on. One final announcement, we've just announced a $17.6 million Alberta government funded program focusing on methane emissions and methane emission reduction. So it's got a number of elements. I think for this audience, the key elements are new technology development and data analytics. You'll see the web address for amap.ca if you're interested in getting involved. This is a 3-year program, and we are hoping to extend it significantly over time to also catch some of the smaller technology developers that are at lower TRL levels. So that's it for me as an introduction, but I do encourage people to visit the AMAT site if you're interested in anything to do with the methane file. Thank you.
Well, thank you, Stephen and Jeanette, for sharing that introduction. And with that, I guess we'll move into our panel discussion. And so let me invite Caro and Brett to turn on their cameras. I'm really delighted to have the opportunity to host this discussion between you guys. And really share the experience of the partnership that started with Husky and then moved to Cenovus, and with Svante to co-develop and really advance the pilot project to capture CO2 from a heavy oil asset. So let me do a quick introduction of our panelists, and maybe guys, if you wouldn't mind just turning on your cameras, that'll help us out. So Brett Henkel is the VP of Strategic Accounts at Svante and co-founder of the company, and instrumental in creating the process and the hardware used to prove the technology's effectiveness, as well as mobilizing external support throughout on the path to becoming a successful innovation and company. And these experiences strengthened his knowledge of business development and program management priorities. And Caro is the senior GHG technology engineer at Cenovus Energy, an engineering professional with over 22 years of experience. In his current role at Cenovus, he is at the forefront of developing current and innovative technologies designed to address emissions in the oil and gas sector. His role involves evaluating existing and emerging technologies, framing the techno-economic fusion with existing facilities to seamlessly generate revenue while abating CO2. And, you know, as we've heard, the Canadian oil and gas sector has been a sort of key partner and globally a leader in advancing CCUS. Caro, can you tell us a little bit about your role, and then a bit about Cenovus Energy and the origin of this project?
Well, I guess you you shared my bio with the group. Right now, what I do is I work with technology providers like Svante and see how I can marry that technology with our existing business, primarily to address greenhouse gas reduction, specifically with CO2 capture. I've been in this space for less than a third of my career. It's been pretty exciting, going through many bumps on the road, advertising this message within the company and the industry. And I would say it's been a successful partnership between myself and Brett. Brett can allude to some of the history. I won't take all the credit because I had some of my colleagues who were very, very involved at the very beginning when Brett, knocked on the door of Cenovus, the company, which was previously known as Husky. And I'll let him speak to some of those exciting events, and I can always compliment his thoughts. But today, our partnership is has opened the door for other competitors in this space to work collaboratively, not to compete against each other, but to collaborate, because we find a technology that can address this concern. We are willing to share because we all are in this space of producing oil and gas, and we want to collaboratively cut back and eliminate the emissions. So that's really, just in a nutshell, the story.
Well, and Brett, how about a little bit of the journey of Svante, formerly known as Aventis, and how it was you came to knock on Caro's door?
Yeah, absolutely. It's been a long journey, and that's part of the challenge. But just to go back to memory lane, our first interaction actually was 10 years ago with Husky. It's now Cenovus, and it started off with just discussions on the concept, because that's all it was at the time. And then it really morphed into a discussion about demonstrating the technology, right? And that's the key when you're talking to a large company about a new technology, is you have to get to the demonstration stage, right? You have to be able to see and touch hardware. So in 2012 was the first participation of Husky in a collaboration with Emissions Reduction Alberta and Sustainable Technology Development. And that collaboration actually turned into an equity round of investment that was led by the Rhoda Group, our first venture capital investors. And then that program went for 2 years, and in 2014 we looked at doing a larger pilot plant and actually put it onto the Husky site. So there was also another collaboration with SDTC and ERA, and that coincided with a equity round of investment led by Chevron. All of these things have to come together at the same time, right? And when you look at the history, they all do. All these events are first sponsored by a major emitter that wants to demonstrate the technology. Government funding comes in and helps to fund that endeavor, and then an equity round of investment can happen from those events. And then, of course, in 2017 was the major investment led by Husky for the 30 ton per day that is operating on the Husky site right now, 24/7. So it's an exciting journey, not without challenges at all, but very, very successful to date.
And maybe over to you, Caro, business case. So, this is a long journey. Obviously, it sounds like, going back to 2012. So here we are, 10 years later. How do you make a business case for engaging with an emerging technology like this? Which one of my former managers at Shell famously called the hardest work he'd ever done for a project that was going to make negative profit.
Very, very good point there. And that proved to be one of the most critical challenges with this project, because we assign capital primarily to generate revenue. So that's really how we do business. But the driver here was, in the very, very early days, even before we met Svante, we've always known that we need to address this thorny subject that does not rhyme with our financial books in terms of our cash flow. And it requires stepping out of the box and demonstrating a keen interest in this space. We've always known it's going to be a dominant issue, but it requires an early start. So it took a lot of push back and forth within the company to carve out funds. It had to be approved executively to cut capital to address this, because and that's one thing the oil and gas industry is pretty good at, from Cenovus all the way to Shell and ExxonMobil. We always ask ourselves, where do we want to be in the next 10 to 20 years? We want to continue to provide the energy the world needs, but it has to be responsibly delivered and it has to be clean. And as a result, the only way to do that is to experiment. Every company has, in its own form or fashion, an R&D research and development group. And when you invest in research and development, you don't expect to get returns. So we capture this under an R&D element. And as a result, we succeeded in cutting some huge funds, millions of dollars we've invested in Svante and other startup companies because of our deep interest to get into this space and ensure that we can sustain clean energy into the future.
Thanks, Caro. Brett, you probably knocked on the door of a lot of different companies. What was one element that you found was really helpful in advancing the initial pilot with Husky, now Cenovus, at that early stage? What
Sure.
Enable?
First you have to find the companies that see the need, right? Even early on, even in 2007, 2008, some companies were embracing that need for technologies around CO2 reductions, and some companies were waiting, right? So you have to find that need, the companies that want a solution. You also have to find companies that are willing to do technology development and are not satisfied with the current technologies that they can use right away, right? There's many companies that, they'll wait. They might need that solution, but they're not willing to do technology development and participate in that, and would rather use something off the shelf, right? There's many companies like that. And then the third thing, which I think is a bit underestimated how valuable this is, that you have to find the champions within the company that see the value in your technology, right? You have to, they have to look at your technology, have the knowledge to look at it, and then go, hey, I believe in that technology. I want to participate in the development of that technology because it's going to bring value to their company, right? You have to find that as a technology developer. So, it takes time, and that's the challenge. It doesn't happen overnight. But when it does happen, it creates so much value because everybody else can jump on board as well then, right? So. And
Caro, I guess going back to some of the conversations that we had during our prep for this, what was one of the sort of challenges that you found that you had to overcome in the course of advancing this partnership with Svante?
So I've been in the field most of my career, directly working in the plant, supporting plant operators doing major and minor projects. And one main challenge is, this is not what we are set up to do. We are an oil and gas company, and our focus is to identify, cash in the ground, extract oil, produce, process, and provide the energy that the world needs. So introducing a different concept from a different that comes with its own technicalities requires that paradigm shift. So that's the number one challenge. This is a new business path. how do we integrate it with the way we traditionally have been set up to do business? So it required a lot of internal engagement, external engagement, conviction, and an understanding of the small and the big picture. So, I like to illustrate it this way. I just saw this on my table. Typically this is how we run. We turn the wheels, we're producing oil and gas, but we have to produce green oil and gas. So this is another wheel. This is what Brett does for us. He has the technology, and we have to demonstrate that we can merge these two and continue to produce green energy. We can integrate innovative technology that can ensure that our business does not collapse, but we can continue to do business responsibly. So that's the number one challenge, the paradigm shift. And it's taking a couple of years, but I can assure you the executives of my company are 100% on board. They are driving this process. Everybody's on board. We don't have, all our projects must have a critical criteria. Does it meet the greenhouse gas reduction projection? So that's how we do business today.
And Brett, how about on your side? I mean, innumerable challenges. There's famously, a real kind of, disconnect in the sort of cycle time between a large corporate partner and a small startup, as you no doubt were in 2012. What was one of the big challenges you found that you had to navigate, and what's some advice you might share with some of our participants today?
One of the biggest challenges is timing and funding, right? So you have to, of course, all funding mechanisms want things to happen very, very quickly, but to bring multiple funding agencies together and the host site of a pilot plant and equity investors together, it all takes time, right? So navigating that, I would say, is a very big challenge. If all the money was just there right away and all the partners were there right away, then technology development can happen very quickly, right? But it's not. Technology development is dependent on funding and dependent on partners, and getting that all in place takes time, right? So I think that's a big challenge. Right now in the CO2 space, there's funding available and there's many partners available. Things can happen faster, and you will see that, right? You will absolutely see technology development happen much faster right now and in the next 5 years than it did in 2010. So I would say that was part of the biggest challenges. Another challenge, which I would say is a challenge for a technology company, but absolutely necessary to go through, is just going from a laboratory development type company and a concept generator and an idea generator into putting hardware on an oil and gas site. That's an incredibly difficult step to do, right? And you can't do without a partner that is willing to do that with you, like Cenovus has done that with Svante. So I'd say those are some of the key challenges. Intellectual property is sometimes a really, really big challenge for a technology developer. We're fortunate in the space of CO2 that, as Caro alluded to, it wasn't their business of CO2 capture and reductions, and still to a certain extent the emitters want a solution to reduce their CO2. They're not necessarily looking at having a business of capturing CO2, right? So there's a good collaboration on intellectual property where we stay out of their business, and for solid absorption, that's us, right? So we can make a pretty good separation on the intellectual property. That's not always possible, right? If we were developing a technology that was directly related to oil extraction, that might be a lot harder to do, right? So we've been fortunate on that. It's really, really good collaboration on that.
Thank you for that. I think that's really helpful. And maybe back to Caro. So now you're, large company, you're working with this small technology developer. there's so many opportunities to say no, let's not advance this. And one of the ones that I know has come up in the past is, well, how are they going to service this if we build this kit and put it on site? Who's going to take care of this in 10 years if something breaks down? How did you guys overcome that perception, or was there something that you did that was helpful in terms of mitigating that risk?
So one exciting thing about my experience with Svante is their openness to admit where they are not able to resource for a certain skill set. I'll give you an example. Their flagship pilot that was built at the Cenovus facility, there was a lot of partnership. They had the responsibility to build it on our site, and we thought we were just going to be spectators, but that's not what happened. We sat on the same round table. We facilitated the commissioning, project management, and most importantly, safe operations and simultaneous operations management. We did it together. So it's the togetherness that helps us to move things to the next level. Another exciting engagement we've had with Svante is as we support them in growing their business to address larger emissions. Yes, obviously, how would they address procurement? How would they address production, meeting the demand? And so we share a lot of information within the boundaries of what we presume to be confidential. So it helps Svante to project how they will support not just their clients in North America, but around the world. And I'm very pleased, every time we give this pushback, Brett and his executive team, they try to address that gap. So Brett can allude to all the engagements and partnerships they've had with big producing companies to help in the entire procurement chain to ensure that they can meet those expectations to supply the necessary parts when we scale up industrially.
Thanks, Carol. Well, I guess we're coming towards the end of the panel, and so maybe I'll let you each maybe close, provide a closing thought. One good piece of advice, as we're about to see several earlier stage ventures present to a collection of partners in the oil and gas sector. There's this opportunity perhaps to take the journey that you guys have been on and use it to inform a similar journey by some of the other participants amongst the over 230 people that are on the call today. So Carol, one piece of advice for your cohorts in the oil and gas sector. What's one piece of advice you'd give them in embarking on this journey?
I would say we don't have time to cross all the T's and dot all the I's. We don't have time. We are behind the eighth ball in helping innovative companies like Svante address greenhouse gas emissions. We need to invest. We need to be ready to fail, but we need to trust that we are going to succeed. But we need to increase our aggressiveness in this space, and this will help us collectively to move the dial, meet our commitment to prevent global average rise in temperature, and also ensure that the world has the energy it needs, but the energy that will not damage the environment, but keep us going.
Thanks, Carol. Take that message of urgency. And Brett, yeah, any advice for your compatriots who are building technologies in this space? How should they engage with the oil and gas sector?
Yeah, a couple of things I'll mention. One is just for the oil and gas sector, and actually all larger companies that are looking for new technologies, is that they underestimate that the power that they have to direct technology development and help fund technology development. Their participation, it doesn't have to be massively big funding, their participation, but their guidance and their interaction is so powerful, and it gets others to jump on board. And I think large companies often underestimate the power they have to do that. The other piece of advice I would give is that equity investments by partners has been incredibly successful for us. So technology development is full of ups and downs. Not everybody likes the downs. And that's something, when things don't work, that's the hard, when you have to go backwards, you have to step backwards. And actually, equity investments and creation of value long-term has helped us get through those times. So I would recommend that. We've had an incredibly successful experience with equity investments with our partners, and we're both going to enjoy the value creation together.
Well, it's a very positive note to close on. Thank you both, Brett, Caro. Thank you for sharing and for being part of this really open discussion. I apologize. I see, a few questions have come in. So what I'll do is forward those to you by email, and perhaps you can respond to them separately. But with that, I'll just confirm that Apoorv, you're ready to go. Our first entrepreneur is coming up. We have 5 companies pitching shortly: Carbon Upcycling, Cemvita, Pi Innovations, Ionata, and AdvEn Industries, representing a mix of domestic and international companies. Each of them will have 5 minutes to present their technologies. And at the 4-minute mark, I'll hold up my hand like this, just to let you know that you're running out of time. Keep your questions, folks, towards the end, but we can obviously take those questions in the chat. So I would encourage you to drop questions in the chat, audience. If you have any, please do identify which entrepreneur you're trying to connect with. With that, Apoorv, you're up first.
Thanks, Jason. Are you able to hear me okay?
Yeah, you're good.
Awesome. So I'll just share my screen here real quick. Let me know if this is coming through here.
Yeah, we can see your screen, and now it's in presentation mode. Go for it. Thank you.
Excellent. Thank you, Jason. And thanks, Brett and Caro, for that session there just now. My name is Apoorv Sinha. I serve as the CEO of Carbon Upcycling. We're a Calgary-based carbon tech company working on decarbonizing cement and concrete through a carbon utilization process. Essentially, what we've found and been able to scale and develop over the last 3.5 to 4 years in particular has been this activation process where we can take a whole range of feedstocks. These could be industrial byproducts, these could be natural pozzolans or even tailings from mining operations. And we've been able to chemically activate them in a batch process to sequester CO2 and to make end products which are cementitious in property, meaning that they can partially replace cements in blended cement, essentially allowing for a lower clinker factor in the final product, or go directly into ready-mix concrete at operations like the ones where you see concrete trucks roll out of. Over the last little bit, we've realized that cement is, I think societally, there's been a realization that cement is a hard-to-abate industry where over 2/3 of the emissions associated with cement production around the world are actually intrinsic to the process. We have found that by activating some of these low-performance materials, we're actually able to create a very proportional and scalable model where local materials can be used to replace clinker that comes out of the kiln, like the one that you see on the left, by activated materials that are produced from what you see on the right, which is a 20-ton-a-day commercial pilot reactor that we've been running now for over 6 months. This allows for not only a lower emission product right at the end of the life cycle, but also a direct sequestration of CO2 into the product that gets to be a part of the recipe. The unit that you saw behind me on the previous slide, and you see behind this delegation of folks visiting our facility from a few months ago, has actually been running like a commercial unit. That unit has now delivered over 1,200 tons of product into the marketplace, into the Southern Alberta market. We've got over 600 hours now of commercial or operational runtime. And we've also shown that the material is compliant with CSA and ASTM regulations. That would be basically the course for field level deployment across North America. This is generally a very arduous process, but the fact that we're taking some of these cementitious materials that have already been looked at within the construction industry for a period of time and using them as a base to further perform the sequestration piece on is one of the reasons that we've been able to expedite the rollout of this, both from a commercial as well as from a regulatory standpoint. Commercially, we've been able to leverage some of the aspects that Brett talked about. I think he's exactly right in what he said about the importance of having equity partners and real engagement by end users. We've been fortunate in the fact that we've now got MOUs with 3 of the 10 largest cement companies in the world. And one of them, as part of our pilot process, is actually a customer of our product. And we've also been able to, fortunately, leverage all the support that is available both in the Canadian ecosystem as well as worldwide through some of the work that we've done. Ultimately, what we see our technology is doing is creating an alternative to what is currently a linear correlation between more cement and more carbon emissions. Essentially, anytime that you want to increase cement production in the world right now, you have to commission kilns that operate at 1400 C and emit anywhere from 700 to 800 kilos of CO2 per ton of end product. Even with cleaner fuels, that number will never go to zero, given just the baseline chemistry.
So what do you need, John?
Richard, would you mind turning off your audio? Thank you. Back to you, Apoorv.
Thanks, Jason. I thought that was you telling me my time was up. So essentially what we found is instead of using conventional kilns to grow cement production, I think it's a well-known fact that cement production is expected to grow over the next 8 to 10 years. We have found a way of delineating and actually producing more cement while reducing emissions, as opposed to keeping that linear relationship that currently exists. And as you can see here at the bottom, we're actually showing that even with some of the projections that we can confidently make now based on the unit that we have running in the ground, our capital costs per ton of end product on an annual basis is actually very competitive compared to conventional kiln technologies that have been perfected over tens of years, if not over 100 years. With that, I'll just finish by saying that we've been able to build up a pretty strong team where we've made up for some of the lack of experience internally with a range of advisors, as well as some incoming investors in a round that we're just about to close. And we believe that this gives us a really exciting platform to go ahead and decarbonize what we think is a very critical industry, not just in our present, but also over the next decade or two as this infrastructure spending goes on full tilt. So again, thank you so much for your time, and I look forward to any questions you may have after the rest of the presentations.
Thank you so much, Apoorv. And with that, I'll ask Roger Harris of Cemvita to join us. And a reminder to please drop your questions in the chat if you have any. Obviously, a lot of people cheering Apoorv on as our sort of homegrown X Prize finalist. Roger, over to you.
Excellent. Well, thank you, everyone, and sorry about that. Sorry about that delay. So here at Cemvita Factory, we have a vision to decarbonize heavy industries with a synthetic biology platform. But before I get started with what we're doing at Cemvita, just a short slide to just recap and reiterate the problem that we all know we're dealing with. No matter what side of the debate you sit on, it is becoming abundantly clear that CO2 and CO2 emissions are a liability for everyone. Reducing emissions and investing in renewables is not going to be enough. At the current rate of CO2 reduction, we will not be able to halt the increase in the atmosphere, let alone reverse the current situation, which is becoming perilous. One of the key industries at the forefront of this perfect storm is heavy industry, which contributes roughly 10 gigatons of CO2 per year to the atmosphere, and the crisis through the reliance on fossil molecules. A future CO2 risk mitigation strategy is key to a profitable business, key to a competitive advantage, and key to a social license to operate. And this brings us to the Cemvita solution. So as I said in the opening slide, Cemvita is a synthetic biology platform with 3 key vertical pillars: CCUS, subsurface CCUS, and biomining. What differentiates us and sets us apart? I'm going to focus on the CCUS and CO2 feedstock. Unlike traditional processes, that use fossil feeds, our synthetically engineered processes are able to use effluent CO2 to produce high-value end products through sustainable biological pathways. This means that instead of contributing to the CO2 burden, our processes enable operators to subtract from their emissions in total. In other words, to produce a CO2 negative product. So how do we do this? And this requires us to get a little bit sciencey. We work with our clients to address their specific CO2 burden and to produce a product X, which is part of their existing value chain. We then use a sophisticated algorithm coupled with bioinformatics and AI and machine learning to identify and develop an optimized biological pathway to that desired molecule X. Next, these optimized pathways are synthetically spliced into organisms so that we can artificially produce the desired product. These two initial stages are at the heart of the Cemvita value proposition. Over the last few years, we've seen synthetic bioengineering decrease by orders of magnitude, much in the same way that computer speeds increased in the 80s and 90s. And this is truly enabling our ability to utilize synthetic biology to produce these products. Finally, these modified organisms are engineered into industrial processes, thus creating the economies of scale and the ability for our clients to seamlessly transition their business to a carbon negative one. So how do we do this practically? We essentially go through several stages of scale up. The first one being the engineering of the microbes and the demonstration at a lab scale. The second one being within the Cemvita factory itself, the scale up to 1,000-liter reactor, and then the subsequent steps after that being a pre-commercial phase, and then the final commercial phase. In terms of looking at a quick snapshot at 2 case studies, our flagship project at the moment is the bioethylene project that we are developing for Oxy. It looks to take 1.7 megatons of CO2 per year and convert that into 1 billion tons of bioethylene. The target productivity for the microbes is set to achieve cost parity or below, and the project itself would enable the client to potentially have a 60 million tax offset thanks to the 45Q program. As a second case study, and one that's very relevant to this audience and to the topic under discussion, we have engineered microbes to be able to produce hydrogen from stranded hydrocarbon assets. So essentially, these microbes are injected into a subsurface depleted oil well, and through their action, produce CO2 and hydrogen. The hydrogen can be extracted and purified, and the CO2 sequestered, thus creating a clean, sustainable fuel from what was once a stranded or depleted asset. So lastly, let me maybe just finish off with who is the team that will deliver all of this. Well, we're a broad and deep team with a wide range of experience, both in synthetic biology and the engineering of microbes, as well as the commercialization and scale up of processes. We've recently just completed our Series A fundraising, and so have a group of Series A backers that have both a industry and a global footprint. And I'd like to maybe just finish off with a paraphrased quote from one of our recent Series A backers. What we have built with Cemvita is extraordinarily impressive. Our platform of bioengineered microbes will have a game-changing impact on the net zero emission journey of the industry. Thank you for everyone's time, and back over to you, Stephen.
Thank you. Thanks, Roger. That was terrific. And I apologize for cutting in, but in order to keep things moving along, I'll now ask Kathleen O'Neill from Pi Innovations to take over our screens, like one of those 1950s science fiction movies. So Kathleen, have you got are you ready to go?
Yes, I am. Thank you.
And while you're getting set up, I'll just remind people to post their questions in the chat, and we'll take those up en masse in plenary. And of course, all of the entrepreneurs will be hosting breakouts following this session.
Okay, can you see the screen?
We
Can
can.
you see the slides? Great. All righty. So I'm Kathleen O'Neill. I'm the CEO of Partnering and Innovation, and some of you may know me from New Wave Hydrogen as well. I have two companies. One is hydrogen production, and the other is carbon capture. And of course, it's not advancing. There we go. So what we have in high innovation is a fundamentally new approach to carbon capture. We work with nature in multiple ways. It's really an elegantly simple solution. We separate gases based on their differential solubility across a pressure gradient. And we use water, a non-toxic, readily available solvent, to separate the mixed gases. That's okay. So how do we get this pressure gradient? To build a pressure vessel on Earth would be very expensive and energy intensive. So again, we look to nature and we use a deep water column. So most of you know, as you go deeper in depth, the pressure increases in water. So we essentially use that pressure gradient from land surface all the way down to about 300 meters or 30 bar pressure. So that creates a nice large pressure gradient across which to separate the gases. We can do it on land in a water-filled shaft or offshore, suspended in deep water. We use, again, hydrostatic pressure for most mixed gases. The acid and non-acid gases actually separate at different or dissolve at different temperatures and pressures. So we're able to use that differential and separate the CO2 from the nitrogen and some of the other gases that are typically mixed in an emission. We have over 8 years of partnering and innovation. We've worked extensively with the Belgium in France, with Norse in Norway, over the past 2 years with several groups, Alberta Innovates and others in Canada, and with DOE National Labs, as well as with the Australian National Low Emission Coal Group in Australia. Again, about 10 years of de-risking and prototypes and pilots with agencies and partners all over the world. With ANLEC, they did a full HYSYS model and engineering cost analysis for our worst case scenario, which was a large 695 megawatt coal fire plant. We were separating the CO2 from that plant. The bottom line was about a $30 per ton, that's USD, total cost of capture, that's OPEX, total burden, CapEx, and including compression of the CO2 product to pipeline pressure. And interestingly, and I think significantly, it's really low risk. In fact, the core innovation has been used in chemical engineering for years. The core innovation is only about 12% of the total cost. So most of the components are readily available off the shelf or commercially proven components. We joke we've made the cover of the Rolling Stone. We made the cover of the Carbon Capture Journal a few years ago. This is our system installed in a lab at the Belgium in Orléans. Our system is composed, it's actually very flexible, very modular and scalable. We have different designs for different end uses. The major components are surface components, which is typically an energy recovery system, and the subsurface components. When we need the energy recovery system, not all designs need it, what we're doing there is capturing the heat and compression energy of the subsurface system and using it to drive turbines to create electricity to offset the parasitic energy demands of the compression. So we compress the mixed gas prior to injecting it subsurface. And to offset that energy demand, we actually recover the heat and compression energy and drive the whole energy recovery system and create electricity. This entire system is the approximate $30 per ton total cost. For many designs, we don't need this surface system. We can just use the subsurface system, and then we're more in the $10 per per ton cost. We have unique integration with a number of different renewables, but in particular geothermal we've looked at for many years, for about 10 years with the Belgium and a program called CO2 Dissolved. And in this, it's very unique in that it allows local CCS. It enables CCS for small to medium scale emitters that actually have no other avenue for CCS. So we can capture the CO2 using PyCO2 and inject it along with the cooled geothermal brine for localized CCS. It's actually lower risk than injecting supercritical CO2. The dissolved brine is denser than the saline water in the aquifer and will sink. It has no escape tendency. So it's extremely safe and a very interesting application. In fact, we've proposed this recently in Canada with Futerra Power. They have a leading innovation project that's funded by ERA and others in Canada. 1 minute. Anyway, involved with Futerra, Global Indigenous Group, Exergy, and others. When we add our PyCO2 system to this, it's actually carbon zero. Zero carbon, okay. We have, again, it's very modular, very scalable, many different end uses. We can separate CO2 from hydrogen, CO2 from, actually CO2 and hydrogen from natural gas reserves and production, onshore and offshore. This is an example of an integration offshore in the Norwegian continental shelf, and we're integrating with offshore wind. Just an image of our one of our prototypes. We have teamed with many partners around the world, many industries, and are working on several proposals and projects right now with some of these partners. Thank you. Thank you for your time. I look forward to answering questions later.
Thank you, Kathleen. That's extraordinary. And I especially love the integration of geothermal and some of this kind of good 19th century engineering. With that, let me turn it over to Ionata and our colleague Russell Maduro. Russ, looks like we've got you set up. Are you able to share your screen?
Yeah, sure. I'll do it via video so that I stay inside of that timeline. So I'll go ahead and share the video right now.
Hello, my name is Eduardo Panzera, Managing Director of Ionata Carbon Solutions. Climate change and the drive to net zero will dramatically change industry over the next decade. Companies that maintain the status quo will face shrinking markets and profits. Companies that implement carbon management will enjoy unprecedented growth opportunities. Ionata's carbon capture technology is the key to enable industries to make that transition. Ionata is the first to market with a patented carbon capture system for small to mid-sized carbon emitters, less than 200,000 tons per year of CO2. Ionata's containerized modular carbon capture system provides a compact and affordable solution for 85% of the industrial carbon emitters. Our target industries include the oil and gas, waste to energy, and marine sectors with no alternative path to net zero. We have successfully completed multiple pilot projects, a quality management team with deep expertise in the target markets. Our National Gas Innovation funded pilot for once-through steam generators to enhance steam-assisted gravity drainage, and a letter of intent for 18 carbon capture systems. Our team includes experienced and successful entrepreneurs, highly skilled engineers, and strong financial leadership. Carbon pricing has increased more than 300% in the past 5 years and is expected to exceed $100 per ton within the next 5 years. Large emitters, those greater than 200,000 tons per year, contribute to only 15% of these total emissions, 85% of the emitters are from small to mid-size, less than 200,000 tons per annum, the target market for Ionata. Competitive carbon capture systems require significant capital investments to build large and complex chemical plants that are only suitable for very large emitters, greater than 1 million tons per annum. Ionata provides small to mid-size emitters access to compact and affordable carbon capture systems. Ionata's sector focus is on 3 key segments: the oil and gas, waste to energy, and maritime. Ionata's key innovation is a combination of 2 proven and mature technologies. The first is the use of amine solvents with over 70 years of proven and reliable performance. And the second is the use of hollow fiber membrane contactors. Our proprietary hollow fiber membrane contactors have an extremely high surface area. In fact, if you were to take a sugar cube of that surface area, it would cover an entire football field. What this looks like physically is similar to a cross-flow heat exchanger. Exhaust gases pass over these membrane contacting tubes. The amine solvent flows through the inside of these membrane tubes, wets the pores of this very high surface area, and absorbs and strips out the CO2 from the exhaust. The benefits of the Ionata carbon capture system is that it's 30% more efficient than competitive systems, with a carbon capture cost of less than $50 per ton of CO2. The system itself is modular and containerized, utilizes regenerable absorbents that are proven and safe. The system itself is simple to operate and maintain, and it's ideal for small to mid-size emitters, and can be easily scaled up with additional units. A common question is, what do we do with the CO2 once we've captured it? Ionata has partnered with a number of CCUS partners for both carbon capture sequestration, EOR, as well as carbon capture utilization, which includes methanation to produce renewable natural gas. We are seeking financial and strategic partners to assist us with our pilot projects and to deliver the next generation carbon capture systems within the next 24 months. Let's explore how we can help you succeed in carbon management. I invite you to join us to helping build a carbon-free world.
Thank you.
It's exactly 5 minutes. I would invite, if there are any questions, I invite everybody to join us in the breakout room later on, and then we can go deeper into the material.
Terrific, thank you. And I guess with that, I'll invite Weixeng Chen of AdvEn Industries to join us now.
Okay, no worries. I can just talk about it. Can everyone hear me?
Yes, we can hear you.
Okay, yeah, this is our mission. Next slide, please. This is a heavy, the middle picture is a heavy bitumen we used to convert 3 products. On the left side is activated carbon, and we have developed a technology that are able to produce activated carbon with a surface area reach to 3,100 meters square per gram as compared to 1,200 meters square per gram of the market products. And we are in the process of converting in the pilot production to convert this heavy bitumen to carbon fibers. And the other product that we can convert this heavy bitumen to true solid bitumen for rail transportation and cargo ships. Next slide, please. Our technology has low GHG emission and using refinery residue, and our GHG emission is 1/3 of the conventional technology, and we used 1/10 of energy to produce our product. Next slide, please. If you in the presentation mode, and you will see the stretching of our electrode,
And we have developed a strong and flexible electrode. And our pilot production of the supercapacitor device is located in Nisku. And we will start production in first quarter of 2022. We can apply this technology to make electrode for lithium-ion batteries and to develop the so-called self-supported current collector-free electrode. And there's many advantages of such electrode, and which is showing here. And our electrodes has a strength of 2.5 megapascal, almost 3 times higher than the strength of the electrode available in the market. Next slide, please. This is our Nisku plant. We are in the process of building the plant to produce with the annual capacity of 300 tons of activity carbon, and we are targeted to have that started production in January by end of January 2022. Next slide, please. That's Innovate, and if you have any questions, feel free to send to us. I'm very sorry for this situation, and I would like to answer your questions in the break room. Yeah. Thank you.
Terrific. Well, thank you all. I see that we have a few questions that came in, and we have about 10 minutes for those questions before we go to breakout. So let me, I see there are a couple questions for Kathleen. So why don't we start with you, Kathleen, and then Weixeng, I think there'll be some questions for you. Kathleen, if you would mind, and I'll ask Apoorv, Kathleen, Roger, and Russell to turn on your cameras so that we can see or hear. Kathleen, what's being done to prevent the CO2 from being reproduced once it's injected into the underground reservoir?
That's a good question. Essentially, it forms when it's dissolved, it forms a dense bubble or a solution that sinks in the formation and tends to travel along the bottom of the formation if it goes anywhere at all. It advances the time to mineralization substantially by injecting in a dissolved form and reduces the escape tendency. So I think what the question is asking is regarding the potential entrainment from the production well. So we have a geothermal production well pumping out hot water for power extraction. Then we have the cooled brine being re-injected with the CO2 dissolved in it. And basically the placement, the design of that system and the placement of that injection well is specifically designed to avoid having that injected water re-entrained into the geothermal production extraction cycle. And if for multiple reasons, one of them is to prevent cold water from contaminating the geothermal source, and the other is to prevent the CO2 from being entrained in the production water.
Thanks.
Does that answer it?
I think that probably goes some way towards answering far better than I was able to phrase the question. So thank you. And maybe a related question would be, do you use amines in the stack column in your technology?
Right. No, we don't use any chemicals at all. That's the beauty of the system. It's just water. In fact, there's no moving parts subsurface either. It's actually density driven. The circulation in the subsurface system is density driven by the gases coming out of solution, and the gases being injected creates a circulation, a naturally driven circulation system. So there's no chemicals.
Fascinating process. And so maybe we'll go back to Roger. I see that you addressed this in the chat as well, but it may be of broader interest, which is, how tough is it to use synthetic biology subsurface? Or I guess another way of framing that would be scale. How are you able to manage scale in a synthetic biology process subsurface?
Yeah, thanks, Jason. Gives me a second bite at the cherry. So good question. Essentially for the subsurface biohydrogen project, we've really focused, especially on the initial part of that project, to use existing technologies. And so there is an enhanced oil recovery technique, microbial EOR, which uses microbes that are injected into the subsurface to improve the oil extraction from low performing assets. We use essentially the same technology to get our microbes of choice and the nutrients down into the subsurface. The action between the microbes and the recalcitrant hydrocarbons then happens entirely subsurface, therefore eliminating a capex requirement for reaction, and the eluted gases, hydrogen and CO2, can then be recovered, separated by conventional technologies, and the CO2 re-injected into the subsurface, while the hydrogen then goes on and essentially becomes gold hydrogen. So in terms of technology and scale up, most of that hardware is essentially off-the-shelf hardware. The real technology development is the development of the microbes themselves, and specifically of the nutrients and triggers and switches that switch on and switch off certain enzymatic behavior, which is the Cemvita USP.
Thank you. Very interesting approach as well. And I think what's exciting about this is so many different approaches being brought together. Apu, I have a question for you. What do you see as the overall CO2 sequestration capacity of your process when fully commercialized in Alberta? Can and I guess related to that, can you use raw flue gas?
Yeah, so we have been doing some testing on how the direct absorption of CO2 into our process is affected by lower concentrations. So I would say it's early days yet to make kind of a public statement on whether we can use it or not. But let's just say that that's a piece of work that's ongoing as an area of focus for us. Definitely, our preference is to couple with a CO2 capture source, because like with any type of chemically driven process, the higher the partial vapor pressure of what you're trying to capture, the better your odds are of being able to do that more efficiently. So yeah, I think there is some early indications that flue gas can still create a viable product, but we have to do a bit of work on that. In terms of the actual kind of direct sequestration potential, I think I'll answer that in two ways maybe. One is to say that concrete is used pretty heavily across the world. So a general rule of thumb is you're using about roughly a cubic meter of concrete for every person in a certain area. So, with Alberta being 3.5 to 4 million, like that's kind of what you'd be looking at. So you're looking at about 1.5 million tons of cement a year that'd be used. And the cementitious material that we deal with, which is fly ash in the Alberta context, would usually be about half of that, maybe a third of that in terms of volumetric use. So all in all, because Alberta has got a lot of CO2 per capita, just because of how our province is set up, we'll only be capturing like a few 100,000 tons of CO2 a year at full scale is basically where the math ends up. Now, the important caveat there is if that is all going into concrete, and one of the main academic, I guess, research angles that we've been exploring is, can we mineralize carbon emissions cost effectively where it can be lower than this progressive carbon tax that's in place now? And if that wasn't the issue, if the idea wasn't to utilize all of that CO2 that goes into the end product in concrete, the number can actually be as high as you want. I mean, it's more an economically driven question, and what we're trying to figure out there is, if we sequester 10 or 20% by mass CO2 into the end product, so 100 kilos or 200 kilos of whatever end product we produce is CO2, can we do that on a per ton CO2 basis for a cost effective number? And obviously that number is still quite high. It'll be in the early kind of 100 to 150 tons a day kind of scale, or dollars per ton kind of scale. And probably even higher than that, depending on where the CO2 is coming from, and if you take the full life cycle into account. So yeah, definitely kind of a more involved question than maybe would seem at first sight, but happy to kind of run through some of those numbers if someone's genuinely interested.
Well, and I'll encourage people who want to dive deeper to join the individual breakouts. But I see a question, Weixeng, on potential applications for your electrode superadhesive. What are some of the potential applications for that technology?
Our technology, ESEC technology, can be used both for making electrodes for supercapacitors and lithium-ion batteries. We can use can be used for both, and we already made electrode for lithium-ion batteries using this technology.
Thank you. And I guess related question. You talked about the bitumen to carbon fiber pathway, but are you also able to do that with CO2?
Yeah, so we could use both activated carbon and activated carbon fibers to capture CO2, used as a hydrogen storage, methane storage. And in both cases, we can achieve very high surface areas. And we can tailor the pore dimensions and for improved capacity of absorption.
Thank you. Russell, there were not very many questions posed to you, but I think I'll pose one, which is, the one of the reasons that traditionally CCUS projects have gone to large scale has been the economies of scale. But you've talked about a modular approach. Can you speak to some of the advantages of the modular approach?
Yes, for sure, for certain. Yes, what we did there is, of course, with the membranes, we have a linear relation in between the capture rate and, of course, the CO2 that is present. And that is very conducive to the process that we have. So that means one module can be as small as a microwave in your home. So our absorber can be very, very small, and it linearly scales up. The problem, of course, with that is if you go above 1 million tons of CO2 per year, that means that the system also becomes very large. But for all of the producers that are below 500,000 tons per year, our system fits there perfectly. And as you know, membrane contactors and membrane technology has always been 30% less energy consuming than the technology out there. And we are using amines in our process, which has been shown to work for already more than 50 years, 50 plus years. So we bring those two technologies to the board and marry them into a new technology that works, and hopefully we can, of course, bring these systems a little bit faster to the clients as well because of their modularity. So they don't have to start at, let's say, 100% capture. They can start at 20% capture. And as the price of CO2 increases in the coming years, they can keep adding modules to go to, let's say, 80% or 100% of carbon capture with our modules.
Perfect. Thanks, Russ. That's amazing. How did they get that photo of me up there? Astrid, would you mind just putting my pinning my video to the screen? And I think we'll probably have a good 90 or 100 people join us in plenary here. Really, this is just a few closing remarks to thank everyone for joining us today. Thank you to the Clean Resource Innovation Network, which represents nearly 3,000 partners across the oil and gas value chain from source to end use, as well as key subsectors, including youth, capital, accelerators, and other partners. We're just very pleased to be able to work with CRIN on this event and our next events coming up in 2022. And of course, I hope and I would encourage everyone to push themselves to find an opportunity to support one of the ventures that they saw today in some way, whether it's a contact, an introduction to someone within their company that can help them advance a pilot or a key commercial milestone, an opportunity perhaps to find other partners or other kinds of support through the network. So thank you all very much. We look forward to your feedback. I'm sure that our team will be in touch and ask for your insight into how we can do these events better going forward. Again, I would perhaps close by just saying, stay in touch, stay informed on what we're doing. And the best way to do that would be through signing on to our fantastic community of innovators, which you can do on our website at foresight.cac.com/events. So with that, thank you all very much for joining us today.